Students, in this video lecture, I am going to discuss solution of page 6, geometrical optics, exercise 2 and question number 4. So in this question is given a boy of height 1.5 meter with his eye level at 1.4 meter stands. Okay. So let's say this is the ground and this is the height of a boy. Height is how much? Height is 1.4 meter. From here to here, it is 1.4 meter. And let's say AC is the height of boy. And here is having eyes. Here he is having eyes. Eyes kept here. Okay. And mirror is kept above the floor. How much this distance? This is 1.5. So mirror is kept at a distance of say 0.8 meter. So mirror is somewhere like this. And this height is how much? From here to here it is 0.8. And this is how much? See it. Okay. And this height is how much here to here? It is 0.75. And you will be getting image here only, right? Image will be somewhere here. Just here you have to apply. This is the place where you're getting the image. So see how we will get the image here. Obviously, see, a person can see only those portion of his body in the mirrors. Okay. From where reflected ray of light coming to his eyes. So one reflected ray of light will come from lower part of the mirror, right? Like this. Correct? So if you extend this, so one image he is getting I1, right? And this portion will be where? Here, right? See. This is a reflected ray of light, right? This you have to show. And this obviously a ray of light may have incidented somehow like this, correct? See like this. Right? So this distance is D. This will also be D. So see, this portion of the person cannot see. And as you can see on top, height of the mirror is more than the what? Person's forehead. So obviously, above that, person will see its full image, right? So person can see this much portion of the image. See here. This much full image except the what? Lower portion. I will call this AD. AD portion will not be visible. So now I'm going to find the value of AD which is not going to be visible. Fine. So in order to do that, I'm going to use concept of similar triangles. Fine. Okay. So how? So similar triangle will be, here you have to find the similar triangle, right? So as you can see here, this is the forehead, right? So how he will see image of his forehead? The reflected ray of light. So one ray of light will go like this, will come back, and other ray of light may have come from somewhere here. No, here, right? See, and if you extend this, you will get image here. So this is the so he is getting only I1, I2 portion, right? I'm going to find this I1, I2 value. So for that, we have to use the concept of similar triangles, right? So this portion will be how much? 0.75. So 0.75. This full thing is how much? 0.75. But 0.8 and person height is how much? 1.5. So this length will be 0.7 only. This is 0.7 only. So it will become okay. And see here, this portion. Now how much is this height? From here to here is how much? This is 1.4, correct? Fine. So 1.4. So I can say, I can apply, see the here similar triangle, right? So you can say here, yes, I1, I2 by I1, I2 divided by this portion. 0.7 is equal to 2D. This is 2D, right? 2D by this is D, right? This is D, this is D. D. So I can say I1, I2 is equal to how much? 0.7 into 2. So 1.4. So person can see his image 1.4, right? I1, I2 is 1.4. So 1.4 from where? From here. From here. So this is, so how much? And on top it is how much? 0.05. So person is seeing only 1.45 meter. Okay. So here it will become how much? Okay. So here person cannot see his feet, right? Feet person he cannot see. This person he cannot see, right? Only 1.45 will see. 0.05 he cannot see the image. His feet, so he cannot see his feet. That's the one way of doing this. Other way of doing the same sum is you can see like this here actually. In this here, you can do like this. See the full height of the mirror, right? Which is going to be new. See here. As to see person's full image, height of the length of the mirror should be half of the person height, right? And it should be installed at a height half of the what? Height of the person, right? So see here how much portion of the mirror is going to be used. So first of all, man length is how much? How much? 1.5 centimeter, right? Man length is 1.5 centimeter. So in order to see his full image, length of the mirror should be 1.5 by 2. So 0.75. And mirror should be installed at what height above the ground? Half of the man height by 2. But man height from where? From the eyes to eyes actually. So this will become 1.4 by 2. So 0.7. Right? So here 0.7. So it should have been installed at 0.7 meter, right? Above the ground. But this is installed at what height? 0.8. So there is loss of how much? 0.8 minus 0.7, so 0.1 meter. So mirror has been installed at a height 0.1 meter above than the requirement. All right. Oh, fine. Now mirror height should have, so here how much portion has gone here? 0.1 gone. So mirror is 0.1 meter above. Okay. Now, so what is the now length of the mirror which is going to be used to form the image? So as you can see it here, so 0.1 simply it's a waste actually, right? So how much is left out? Just from 0.75? Okay, 0.7 is going to be used to see the image because 0.5 meter is above, so that is not going to be used, right? So only 0.7 meter is going to be used. Fine. So 0.7. So double of that is how much? 1.4, correct? So 1.4. Okay. So 1.4 from where? 1.4. Okay. At above that, how much? 0.1 by 2, so 0.05. So add 1.4 plus 0.05, so it will become 1.45 meters. Correct? So this was only he can see. Okay. So we'll, this is the solution of the question. Okay. Thank you.